Good evening. I'm Crystal Logan. Welcome to the Aspen Institute. I'm the Vice President of Aspen Community Programs, and I'm delighted to welcome you to this very special event. Tonight's event is part of our newly launched Advancing Women's Health series. I'd like to extend special thanks to Meredith Loring and Sami Inkanen for their vision and generous sponsorship of this program. Thank you so much, Meredith and Sami. Thanks also to our Aspen Society and community donors, as well as our trustees who are here with us tonight, who also support our work very generously. So thank you all. It's an honor to welcome our featured speaker, Dr. Emily Jacobs. Following her remarks, Dr. Jacobs will be in conversation with Carolyne Heldman Rovira, who brings 35 years of experience in media. Carolyne is currently the host of The Lens, a nonprofit news organization based in New Orleans, and she was formerly the executive director of Aspen Public Radio. Dr. Emily Jacobs is a professor of neuroscience at UC Santa Barbara and director of the Ann S. Bowers Women's Brain Health Initiative. Her research is transforming our understanding of the brain's capacity for change across the lifespan. And in 2024, her team created the first detailed map of the human brain across pregnancy. She leads major multi-center studies on neurological changes associated with menopause. Before joining UCSB, she held appointments at Harvard Medical School and Brigham and Women's Hospital, and she remains a leading voice in advancing women's health research through national and international collaborations. She's also deeply committed to expanding opportunities for STEM, for girls in STEM, and she partners with many K-12 programs. A graduate of Smith College and UC Berkeley, she has been featured in many outlets ranging from the New York Times to Nat Geo, NPR, TED, and more. So please join me in giving a warm welcome to Dr. Emily Jacobs. Thank you.
To be here tonight. I just have to start by giving my thanks to the Aspen Ideas program, the community program, and what an extraordinary thing for them to be launching this new women's health program. So there's going to be more of these. You have to come. And I want to give a special thanks to all of you. It is a Tuesday night. It is beautiful. You could be almost anywhere, and you chose to be here, and that's a pretty remarkable thing. So yeah, thanks for having me. So the title of my talk is New Frontiers in Women's Brain Health. But the sort of harmonic or overtone that will weave its way through this talk is this concept of the uncharted mind. I want to start by putting this moment in its broader historical context. As a society, we have underinvested in women's health research since record-keeping began. Think back to the time of antiquity when Hippocrates proposed that a woman's womb could wander around her body, wreaking havoc. Or the time of Charcot at the Salpêtrière in France, where hysteria was handed out as a diagnosis for any female pathology that physicians failed to understand. And our lives depend on medicine learning to listen. So let's maybe start. I want you to take a look at this short film that sets the stage for why we're here.
Let's start with some good news. Neuroscience is having a moment. We are learning more about our brains than ever before. Over 50,000 neuroimaging articles have been published since 1995, shedding light on the most complex organ in the human body. Of those 50,000 articles, about half of the test subjects are women, and yet only half of 1% center on matters specific to women's bodies. Wait, that can't be right. Half of 1%? Guess that brings us to the bad news. Half of 1% is so damn small. It's this small and this little. If you made a pie chart let's say boysenberry. Half of 1% is that. There. That's the entirety of what we know about brain health and the fork crumbs.
Here's a list of things we know more about than the female brain.
The ocean floor. Male pattern baldness.
Dinos.
Erectile dysfunction. How to make erectile dysfunction medicine chewable and yummy. Artificial sheep uteruses. LeBron James's off-season diet.
Outer space.
Outer space. Meaning if men really were from Mars and women were actually from Venus, we might know more about menopause by now. Even in cases like Alzheimer's, which mostly affects women, preclinical research relies on male models. The assumption is if it works for men, it works. And that doesn't work. The most recently approved Alzheimer's drug shows positive effects primarily in men. One size fits all is actually one size fits half. And in this case, it's the wrong half. When 99.5% of all neuroscience research excludes matters of women's health, mysterious things stay that way.
Why do women get Alzheimer's more often than men?
Is my birth control making me depressed?
Are concussions different in girls?
Why can't I remember anyone's name anymore?
Why am I so sleepy,
Sad.
hungry?
Am I undercaffeinated or is this
A menopause thing?
Jury is still out because nobody bothered to put any women on the jury. The male body has been the standard since always. Lab rats, male. Clinical test subjects, men. The tenured neuroscience faculty, 80% tweed elbow patches. But what if, maybe, what if we set fire to the status quo? Demand better, broader data.
Study women.
Thousands of them. We start a revolution in neuroscience. Or join those who already have.
Okay, so for the next 35 or so minutes, we're going to follow in the great Shakespearean tradition of a story in 5 acts. Act 1, Mind the Gap. Let's turn our attention to what brought us out tonight, this incredible 3-pound mass of tissue. At first glance, it looks pretty unremarkable, but if you zoom into the microscopic level, it contains multitudes, over 85 billion neurons that are wired together into precise circuits. And these neural circuits are responsible for an almost unimaginable range of complex behaviors. Like, think about it. That is capable of writing an opera. It can invent tools that allow us to see into the deepest corners of space. And perhaps even more profoundly, the human brain can invent tools to see and study itself. So when President Obama launched the Human Brain Initiative back in 2013, he said that understanding how the brain works is one of the greatest scientific challenges of our time. It's the moonshot of our generation. And around the world, we have neuroscientists like Dr. Caitlin Taylor in my lab at UC Santa Barbara who are trying to crack the neural code to understand how the brain gives rise to the mind and to identify therapeutic solutions to devastating disorders like Alzheimer's, Parkinson's, and depression. If we have any hope of meeting these challenges, we need the best minds in the table and at the lab, inventing radically new ways of seeing, probing, and ultimately understanding the brain. And that's what I want to talk about in Act 1. So the problem is that our science is hamstrung from the start. Biomedical research relies on animal models, like this one, to understand diseases, to test new therapeutic treatments, and to advance knowledge of basic biology. And as you learned from the video, this research is conducted almost exclusively in males. That over-reliance on male animals is evident throughout the biomedical sciences, from neuroscience to immunology to pharmacology to cancer biology, and it's been true for half a century. Here's the kicker. It's even true for animal models of human disorders that are more prevalent in women, like Alzheimer's, depression, and anxiety. We know that this bias is compromising the health and safety of women in ways we're just beginning to understand. By some estimates, up to 80% of the drugs and medical devices that are pulled from the market are done so because of adverse effects specifically in women, effects that might have been caught had that earlier preclinical testing included both sexes. These are not new problems. As the British historian Eleanor Cleghorn writes, our bodies are not elusive to us, and yet something about our bodies seems to thwart and frustrate medicine at every turn. And again, our lives depend on medicine learning to listen, but we're not listening. So to put real numbers on the problem, let's consider a second example from my field of neuroscience. When magnetic resonance imaging, or MRI technology, entered the mainstream in the 90s, it gave scientists incredible ability to visualize the living human brain, right? For the first time in really exquisite detail. It gave us a better way of understanding how it works when it's healthy or what goes wrong when it's not. So over the last 25 or 30 years, we know that over 50,000 brain imaging articles of the human brain have been published, represented by this blue wave, if you will. And then if you squint really hard, there's actually data points at the bottom in black. That is everything we know about how the brain responds to pregnancy, menopause, the menstrual cycle, preeclampsia, gestational diabetes, and so much more. That's the data, the fork crumbs. So when we talk about the scientific body of knowledge, I think it begs the question, whose body does it serve? Menarchy, pregnancy, menopause, these are health inflection points, and they deserve our attention, but we're not paying attention. Women are 51% of the population, but less than 10% of NIH funding goes to conditions that primarily affect women. And I just want to remind the folks in this room that it took an literal act of Congress to require the enrollment of women into clinical trials. And does anybody know what year marked the first White House conference on women's health? Any guesses? 2024. 2024. Yeah. So it has become clear to so many of us that advancing women's health will require a global shift in science culture. And we're paying a steep price for our collective ignorance. A World Economic report published recently suggested that if we could eliminate the women's health gap, it would unleash a $1 trillion return on investment every single year. So whether you're driven by moral urgency or economic reality, investing in women's health is the way forward. So in these next few acts, I want to convince you that some of the topics neuroscience has systematically overlooked are in fact deeply important for understanding the brain. And these topics may hold clues that can enhance brain health for everyone. To understand why, let's consider two features of biology. First, the brain is an endocrine organ. The menopause, the menstrual cycle, it actually originates in the brain. The brain, through its hypothalamic pituitary axis, will direct the release of hormones from peripheral endocrine glands. And reciprocally, once those hormones are released, hormones use your cardiovascular system as their superhighway. They go everywhere your blood goes, including the brain. The brain is a major target organ for these steroid hormones. Second lesson, hormone secretion varies over time, right? In fact, this is a fundamental feature of the mammalian endocrine system. We have these ebbs and flows that drive physiological changes throughout the body, but until recently, nobody really appreciated how they influenced the brain. Here's a depiction of some of the major endocrine transitions that can occur across a lifespan, right? We have I think I have a pointer on this guy. We have the pubertal rise in estradiol or estrogen, which is actually a family of estrogens, estradiol and progesterone. We have the menstrual cycle. For 80% of women around the globe, we'll have this surge in hormones around pregnancy. And then for 100% of women who live to midlife will experience endocrine senescence or menopause. And what scientists are now realizing is that these endocrine transitions are actually health transitions. And for neuroscientists, we're realizing that these dynamic endocrine events can drive enhanced plasticity in the brain. The flip side to this superpower is that when brains change rapidly, it opens up windows of vulnerability. So, for instance, we know that depression is heightened during these major endocrine transitions, from the pubertal onset of internalizing symptoms, which I'll show data in a second, to peripartum depression and perimenopausal depression. We also know that early menopause, especially if it's before the age of 40, has been tied to increased dementia risk and an autopsy increased burden of neuritic plaques. Knowing this biology could open up avenues for prevention and treatment, but guess what? We got to study women. Here's an example of this enhanced neuroplasticity in the brain tied to the menstrual cycle. So you're looking here at an individual brain cell. This is a neuron in the hippocampus of a mouse. And then if you zoom in, you can notice these little, where's my pointer? These little bumps or protrusions, right? These are called spines, dendritic spines, if you will, and they allow neurons to form synaptic connections to other cells. This is the mechanism that underlies neuroplasticity. So if you've ever heard the phrase cells that fire together, wire together, this basic concept of Hebbian neuroplasticity, that's mediated by these spines. And what's remarkable is that Catherine Woolley in 1992 noticed that the density of these spines actually gets enhanced right around the time of ovulation. Right here, right? You don't need statistics to show that there's way more spines here than just a couple days prior or 24 hours later during estrus. And fast forward to present day, we now have access to some of the most advanced imaging techniques on the planet that allow us to observe these changes in animals in near real time. This is work from the Gord lab at UCSB. He's actually in the audience with us right now. He developed these techniques for ultra high resolution imaging of hippocampal neurons. We get these exquisite resolution. And just as Woolley predicted, we can actually observe this enhancement of spines, right? This enhanced plasticity during periods of peak estrogenicity, which are demarked here by these asterisk points. So we can actually observe this pulse in the brain that keeps time with the rhythmic ebb and flow of hormones. Now, a 20% change in spines may not seem like all that much. It actually represents hundreds of millions of synaptic connections. Who knew? Okay, what about in humans? I want to show you some forthcoming work from an incredible postdoctoral fellow, Carolyne Heldman. This work is under review in Nature Medicine as we speak. And she analyzed brain imaging data from over 5,000 girls who were followed longitudinally across adolescence. And she discovered that the start of menarche represents a major inflection point for brain development. So this dashed line here is a person-specific menarche stage, because obviously some girls go through it earlier, some girls go through it later, and if you just stack the deck, instead of by chronological age, but by menarche timing, she shows that that is the key inflection point that's driving brain maturation. So all of this wonderful cortical refinement and remodeling and pruning of excess synapses and this expansion of gray matter volume, all of which is crucial for healthy brain development, that process seems to be kickstarted by the onset of menarche and then the rise of hormones that happen with a girl's first period. How is it 2026 and we're just realizing this? And remember what I said about periods being this rapid, the periods of rapid brain growth are sort of both a superpower and a potential window of vulnerability. Well, what Carolyne found is that menarche is also marks an inflection point for the rise of internalizing symptoms like depression and anxiety. Here's the time course, here's menarche timing, and notice when this inflection point occurs. It's right after menarche starts. So we have got to start recognizing menarche as a core developmental marker in neuroscience. Clinicians can leverage this concrete biological event to identify the window of mental health vulnerability and when it opens for each individual. And so instead of recommending screenings based on these broad age ranges, we should be anchoring our mental health screenings to Menarchy, right? It is a much more precise identifier of when that window of vulnerability opens. And I think it's hard to see those data points now, but if we just use chronological age itself, we could be off by as much as 3.5 years. But if we tie it to this sort of gynecological age as opposed to chronological age, we can get much more precise and capture girls, closer to the event and obviously intervene faster. Okay, let's turn to Act 3, matrescence. So, I've just shown you some of the neuroplasticity, some of the sort of brain effects that can happen across the menstrual cycle. But we know that the endocrine changes that occur across the menstrual cycle are dwarfed by those that are observed during pregnancy, right? This cycle is all contained in this tiny period. So what on earth is happening to the brain during pregnancy? Well, buckle up, because the first MRI of the human brain happened in the 1970s, and the first MRI study to capture brain changes during pregnancy was published in 2024. Wah, wah. So we had an extraordinary opportunity to answer this question when a neuroscience colleague of mine, Dr. Liz Krastel, said she was planning a pregnancy, and it was going to be with IVF, so we knew the point of conception. And so we were able, my lab specializes in something called precision imaging, where we can follow people over these sort of exquisite high-frequency time series. So a couple years ago, we mapped the brain across the menstrual cycle. And so following on that work, we were able to capture her actually in the preconception phase. We followed her throughout up to 2 years postpartum. So actually these hatch marks here represent every time she came into the lab, and we got these exquisite high-resolution images of the brain and its white matter structure and its cerebral perfusion. And she donated blood so we could look at sort of proteomics and the endocrine profile. Just to sort of show you this incredible endocrine transition that's happening. This is her data. This is estradiol and progesterone levels as it's skyrocketing across pregnancy. And then, of course, what happens here? Parturition, birth, right? There's this plummet. And so what we can do is create these sort of maps of different tissue types and how it's changing. So again, this dotted line here is birth. And we can see that gray matter volume, cortical thickness, it's all showing this reduction starting from preconception to the point of birth. A little bit of a sort of rebound in the postpartum period, but not to the preconception baseline. So these, what we now understand, are these sort of permanent etchings in the brain that get laid down during this massive endocrine transition. So gray matter volume is going like this. In contrast, the volume of cerebral spinal fluid in the ventricles are expanding. So a couple sort of take-home points that were a surprise to us is that this honing or sort of refinement of gray matter across pregnancy is really evident across the cortical mantle. And if we so every area here in blue is an area that showed a statistical change with pregnancy, with gestation, or gestational week as it progressed. And if we just hone into, take your pick, any one of these, we can plot these changes as they're occurring week by week across the gestational period, or by preconception, first trimester, second trimester, third trimester, and then again, the postpartum period. Now, I mentioned that my lab focuses on something called precision imaging, where we can map individuals over time. And so we can get these really kind of high-fidelity maps of sort of the time series of these changes and how they're happening. But these are highly choreographed changes. So I have yet to see a case of somebody a woman who did not experience these changes, and we can see this in our collaborators' work who've now published work from a cohort study, so hundreds of women a few times throughout pregnancy who are showing the same curve. And we always get asked the question, well, what happens about, subsequent pregnancies? Do we get more kind of cortical refinement, more etchings? And so we went back and we did that study too. This is actually work from PhD dissertation of my graduate student, Hannah Grotzinger. And so you can see first-time pregnancies are in gray. Second-time pregnancies are in blue. And sure enough, we're seeing the same kind of refinement happening, maybe just a little bit less each time, but it's still there. So this kind of additional honing with subsequent pregnancies. Now, just like in adolescence, where that sharp pubertal rise in hormones will trigger a reduction in gray matter volume and an increase in white matter connections, we see the same thing during this period called matrescence. So white matter is expanding. And so what we're really thinking is that this is an extended period of neuroplasticity in the adult human brain. And it's just, it just kills me that neuroscientists had this idea that after puberty, that's it, the brain's sort of done. Sure enough, it was happening in half the population. We just didn't bother to look. So pretty extraordinary what the brain is capable of doing when we pay attention to it. And you can read about this work from other groups, including NPR. And I know there's sort of an NPR station in the audience here, so go support your NPR station. This made me laugh. Just a couple weeks ago, I opened the Sunday Times and stumbled across this ad. I don't know if people know what IDGAF means, but I don't give a is in the dictionary. Matrescence isn't. It's time to give a about mothers. Amen. So this project has expanded rapidly into an international effort that we call the Maternal Brain Project. We have experts in neuroscience, reproductive immunology, reproductive psychiatry, proteomics, and AI that have all joined forces to learn as much as possible about this transformative period. Why? Because women's brain health scholars lack the most basic substrate for discovery: data. We don't have the data we need to predict postpartum depression before it manifests. We don't have the data we need to understand the effects of preeclampsia on later life brain health. We need better data. And paying attention to this critical window could hold clues that enhance brain health for everyone. And props to our AI team who won Time Best Invention of the Year this year for their work developing a digital twin model of these brain changes across pregnancy. Okay, Act 4 brings us to midlife. We are at menopause. It's important to know that during the menopausal transition, 80% of women, 80, will experience neurological symptoms. In fact, the cardinal symptoms of menopause are brain symptoms: hot flashes, sleep disturbances, brain fog, mood changes. These are all originating in the brain. People sort of always look at me a little strange when I say hot flashes, but remember that that actually has to do with the brain's thermoregulatory circuits getting a little bit unused to the fact that estrogen is not providing that negative feedback signal anymore. That's a brain symptom. And yet we are just beginning to understand how the human brain adapts to this period. And there are no tools to monitor or guide brain health decisions during the midlife menopause transition. And it is not just the scientists who are stumped. I want you to check out this clip from two women who you know, who have access to the best doctors on the planet.
It's a trip. you know, it happened to me around 52, 53, and I thought I was dying. I really did, because I did not have, did you have hot flashes?
I was able to, I started hormone therapy.
Okay, so yeah. I didn't know nothing about that.
See, and that's what we didn't know.
That's what I mean. People don't talk about it.
And here's the thing. People don't research us as women. Why don't we know all about this?
Yes, and why don't we? This time in life seems so unknown and yet is absolutely knowable. Again, as women, we will live almost half of our lives in the peri- and post-menopausal years, and yet the more we learn, the more scientists realize this is a critical window for preventative care. So we launched the Longitudinal Menopause Project to generate one of the most detailed examinations of brain health and menopause in the U.S. to date. This is a multi-site study that unites several of our University of California campuses. We're rolled out at UCSF, Santa Barbara, San Diego. We have 2 sites at Berkeley and Harvard waiting in the wings. I know that Aspen and Santa Barbara, San Francisco, these are sort of like sister cities. So if anybody's interested in joining our participant registry, just pop your phone at that, or in the foyer, there's information. We would love to have you. This gives you sort of a glimpse of the types of data that we collect. So every year, DEXA scans, 2 brain MRI scans, blood draws, so on and so forth. Why bother conducting a study of this magnitude? Because there is so much about the biology of menopause that we don't understand yet. And it's not because women are too complicated. It's not because menopause is like the Gordian knot of biology. It's a reflection of the fact that we have underinvested in a phenomenon that is going to affect half of the global population. California and the Women's Brain Health Initiative can lead the way, because remember, menopause is not just an endocrine transition, it's a neurological transition, it's a cardiovascular transition, it's an immunological and metabolic transition, and our study is designed to capture each of these elements. I want to just give you kind of briefly a taste of some of the discoveries waiting to happen. So I want to give a shout out to Professor Caitlin Casaletto. She's a professor of neurology at UCSF, and she's starting to tease apart the mechanisms connecting menopause to later life dementia risk. She directs the WBHI's Biomarker Analytics Hub. And so using early data from a precursor study to the Longitudinal Menopause Project, she's identifying these molecular signatures of menopause that may be important for future Alzheimer's risk. So we use data from women who are pre, peri, or postmenopause and age-matched men. Through their blood, we can do both high throughput and targeted proteomics. In this case, I'm going to show you data from a panel of 120 proteins that are known to be risk proteins for dementia. So this has been sort of worked out through the Gates Ventures backed Global Neurodegeneration Proteomics Core, and in partnership with them, we've been looking at it much earlier in life, sort of in midlife. And so what do we find? So the UCSF team discovered that in some women, menopause is associated with these increases in inflammatory, synaptic, metabolic, and neuropathology markers. So of the 120 or so panel, there's about 16 of these proteins that are upregulated. And this menopause risk panel tracks very strongly with a hormone called FSH, follicle-stimulating hormone, which is the pituitary hormone that actually goes up with endocrine aging. Everybody sort of thinks about estrogen going down, but it's actually driven by FSH going up, and in some women, they'll have higher levels of FSH postmenopause. And these data are not, we don't see it as a function of chronological age. So in our age-matched men, we're not seeing the same change, suggesting it really is something about endocrine aging, not chronological aging. We also see that women with the most vasomotor symptoms, hot flashes, night sweats, show this sort of exaggerated elevation of these risk proteins. That's really important to know because we have great treatments available for vasomotor symptoms, and maybe that's something we'll get into in the Q&A. Our team also recognizes that in addition to data, we need to do some serious policy work to improve menopause care for women around the country, certainly in our state of California. So, we can ask the question, like, how come in the year 2026 we don't have answers to fundamental questions about our body? I think it starts with education. According to a Johns Hopkins survey, about 30% of medical schools fail to include, only 30% of medical schools include menopause in their basic science curriculum. 70% fail to do so. And for those that do, the courses are mostly an elective. So if you need the bumper sticker, here it is. Women's bodies are not an elective. And a module in menopause in graduate school is not enough. So back in California, we have incredible leadership from Assemblymember Bauer Kahan, who pushed her advocacy of AB 432, this Menopause Care Equity Act that would establish continuing medical education programs so that doctors are trained to know, all doctors, that it can't just fall on the burden of OB-GYNs. We need neurologists, cardiologists, everybody to have a basic proficiency in this. The bill also would require medical insurance to cover menopause care. And it passed with overwhelming bipartisan support through the Assembly and the Senate. And then in the 11th hour, Newsom vetoed the bill. And he did so during Menopause Awareness Month. Yeah, oof, we're still licking our wounds on that one. But the silver lining is that, that discussion led to the appropriation of about $3 million to every UC campus that has a medical school. So UCLA has really been a leader in establishing one of the first ever comprehensive menopause care clinics led by Rajita Patil. And so we now have state funding to kind of cookie cutter that model across our other UC sister sites to expand access to care. And I will say there's some good news that after he vetoed the bill, he went on blast, and again, maybe we can get into it in the discussion, and he's now essentially salvaged everything that was in the bill in the most recent budget appropriation. So we're kind of playing catch-up, but it looks like using our voice is an incredible collective power. And finally, Act 5, filling the gap. So I think that moments like today are both a celebration and a call to action. So it's clear we have work to do. We owe women a century of science, and we can't take another 100 years to get the job done. So the WBHI launched in the end of 2023 with early foundational support from Ann Bowers. We're an endowed research consortium with research spanning 9 institutions, and we are united in our mission to shine a floodlight on women's brain health. I've mentioned 2 of WBHI's moonshot projects, so the Maternal Brain Project and our LMP project, and I want to just tell you about one more quickly, which is our WBHI Brain Bank. So when so much about women's brain health is understudied, right, the fork crumbs, knowing where to shine a spotlight is a challenge. Our mission of the WBHI Brain Bank is to address this challenge and to build the most diverse and comprehensive collection of data ever acquired for women's brain health. Our brain bank takes advantage of the single most important feature of the University of California, which is that we're actually one university with 10 campuses spread out across a geographically and demographically diverse state, 4th largest economy in the world, 12% of the world's, 12% of the U.S. population, 27% foreign-born. On our own, our UC campuses rival other leading institutions, but you put them together and there's almost no other university system like it on the planet. So the WBHI is really dissolving these institutional silos, rewriting the rules of how science is done. We've built the pipelines to integrate MRI data that's collected across these 7 brain imaging centers, and then we pair that data with neglected information on women's health. All of that goes into a central repository. We have a data core at Stanford, and ethos of the WBHI is that once we collect the data, we give it away. It's de-identified, so but it's open to the global neuroscience community to drive discovery. This is a consortium science approach that sort of harkens back to the model of genomics or particle physics, where massive amounts of data are collected through joint endeavors. We know that embracing big data ushered in major discoveries for those fields. We can do the same for women's health. We can study tens of thousands of women in ways no one else has, and with data that we can generate when we work together. And so, this has been live for a year. We already have, as of today, well over 2,000 scans banked. This is a huge incubator for discovery science. Okay, when you think about the status of women's health, it's easy to get angry, but there is actually so much to be hopeful about. Yes, we have major gaps to fill, and I think any serious solution to that challenge means cultivating strategic partnerships with stakeholders across academia, government, business, and media. The WBHI is a springboard into these kinds of public-private partnerships. We have foundations like Fidelity, Welcome Leap, Pivotal Ventures, the Foundation for Women's Health that are stepping up to fill major gaps in research funding. We have leaders like Boston Consulting, McKinsey, JP Morgan that are using their platforms to make a very strong business case for investing in women's health. We have state legislatures that are pushing to improve access to menopause care. And we have our friends in the media, right, like the ever lovely Halle Berry, Lupita Nyong'o, who are lending their power to the cause. So when I take a step back and I think very audaciously where I'd like the Women's Brain Health Initiative to be in 10 years, I want to see the UC become the global epicenter for women's brain health with research and policy and training arms that bring the best minds to our collective campuses to make breakthrough discoveries. And to close, the American novelist Henry James encourages us to live our lives finally aware and richly responsible. If James is correct, I think it means we can fail in two ways, by being obtuse or negligent. My guess is that everyone in this room lives up to the Jamesian ideal. Right? We're acutely aware of the problem in front of us, and we have a profound sense of responsibility to do something about it. The WBHI is a radically collaborative effort. It requires engineers and data scientists and MRI technologists and neurologists and women's health scholars and brain imaging center directors and an operations team working in concert. This is the opposite of siloed science. And the folks behind the WBHI, including the 90-some scientists that are contributing data, or the 800 of us who are part of the monthly seminar series, or the 5,000 of us from 100 countries around the globe who joined our first ever AI Datathon for women's brain health. Together, we know that a global shift in science culture means a radical reimagining of how science is done. And these are the people to do it. So let's start a revolution in neuroscience tonight. Let's ensure that our scientific discoveries serve society, not the fork crumbs, but the whole pie. If you're in Santa Barbara, I encourage you to come visit us. And I have to give thanks to the incredible team of scholars who actually generate this data. In addition to those at the WBHI side, here's my lab side. I just get the privilege and pleasure of being able to share their data with you. And if you're ever on the West Coast, we have some upcoming seminar series you are most welcome to. You can sign up here. We'll hear more about the neuroscience of motherhood and from Rajita Patil, new models for menopause care. And with that, I want to thank you for your attention.
I'm really hot. Oh my God.
We have options.
Yeah. Thank you, Dr. Jacobs, and thank you, Crystal, and the Aspen Institute for the privilege again to be here on the stage talking about something that affects half of us, and me in particular right now. I want to start, there's something you put up on the screen that I either passed by when I first looked at it with you, or it might be new. But, well, hang on. Let me ask this first. The hormonal changes that we experience across a lifespan, what do we understand about how it affects our cognitive health?
Yeah, I mean, I think what we're now appreciating is that, again, these major endocrine transitions, they're health transitions. From a neuroscience perspective, we often care a lot about sort of mental health. And that's, I think, what this data is starting to show is that suddenly we can understand, from an epidemiological perspective, we had this data to show that these endocrine transitions co-occurred with the onset of sort of mental health, the sort of precipitation of mental health, obviously not in all women, but in some. Now we're starting to see sort of under the hood, like what are sort of the brain changes that might help us distinguish a woman who is on the path to a sort of typical trajectory versus those that might be on the path towards something that's atypical. And that's what I hope that some of these data can help us understand. So as an example, with our maternal brain project, our motivation there is actually with this sort of precision imaging where we're scanning people starting preconception, certainly before a peripartum depression has occurred. Our hope is that whether it's in brain or in blood signatures, we might actually be able to come up with a biological signature before behavioral symptoms actually manifest, so that we can intervene earlier. But yeah, I mean, the brain is an endocrine organ, so it's responding to these hormones in all kinds of really amazing, great ways, like the neuroplasticity that I showed you. But again, the sort of flip side of that coin is that sometimes when brains change really rapidly, things can go awry.
Okay, and the slide I'm referring to, you talked about the neuroplasticity in the brain and the hormonal changes in the gray matter that was building, especially during pregnancy. It almost suggested to me, the way you described it, it suggested to me that pregnancy should be recommended. It should be prescribed to every woman for long-term health.
As a neuroscientist, I could say yes, but obviously there's a huge ramification for the whole body. So maybe, yeah, look, I think the pregnancy stuff is really interesting. So remember, it's actually a reduction in gray matter volume, and sometimes people stand up a little, sit up a little straight, like, ooh, that can't be good, like my brain volume's decreasing across pregnancy. And I think that the way to think about it, the analogy I always give is sort of like Michelangelo's David. The artist starts off with a big block of marble, and then the beauty is revealed through the art of removal, right? He chips away, and then the sculpture is formed. And that's what's happening during pregnancy. So we're sort of seeing gray matter volume reductions. And again, that is the same process that happens during adolescence. Hormones flood the system, the brain gets sculpted. And as I mentioned, there's actually neuropathologies, neurodevelopmental disorders that happen if that sculpting does not go according to plan. It's actually a really essential process that all of us in this room of all sexes and genders will go to. But yeah, women have this sort of unique superpower in adulthood, in our 20s and 30s and even 40s, showing another wave of cortical refinement tied to pregnancy.
So these changes that occur during the stages, they are forever altering the brain structure?
Great question. All signs point to yes. So we've followed individuals up to 2 years postpartum. We see a little bit of a rebound, but not all the way to the prepartum state. I have a colleague of mine that's followed people up to 6 years, and they still see it. And probably the biggest evidence that we have, there's something called the UK Biobank. It's this big data repository that Europe put together. It's women and men in their 40s and 50s and 60s. But even in that age range, this is work from Anne-Marie Delange, she was able to use machine learning from a single brain scan collected from an adult in their midlife period, 40, 50, 60s, determine the parity status of that woman, whether she had no kids, 1, 2, 3, or 4, based on the MRI alone. So what that tells us is that we're carrying those sort of etchings with us for life.
Okay. You touched on this just for a second, that some people are more susceptible to the hormonal changes and the symptoms that are associated with those. What do we know about why some people are more and why aren't others?
I think that's the million-dollar question. I think that's where the science is trying to go, and it depends on exactly, I think, the topic that we zero in on. There's evidence, in fact, join our seminars series, because we just heard last week from Lauren Osborne, who's doing beautiful work on peripartum depression and looking at allopregnanolone, which is a derivative of progesterone, and trying to understand whether either genetic tweaks that affect allopregnanolone or levels of the hormone itself might be an indicator. We actually have the first FDA-approved treatment for peripartum depression that acts on that biochemical pathway. So that's one clue. But I would say and this is just such a disappointing answer, but like the science is like in inch one of the marathon.
Based on all of your research, I'm going to ask you a pretty personal question. You have a 12-year-old daughter, your mom's here, you're, I don't know how old you are, but you've clearly been through a pregnancy. What do you recommend? What do you give your daughter? What are you telling her to do? What does your mom know from you about what to do for our brain health?
Yeah, well, not to throw my daughter under the spotlight, but we talk about hormones all the time in our family, so menarchy, menopause, it's all very familiar terrain. I think that's one of it, is just normalizing these topics. I think for so long, menopause has been shrouded in stigma and in shame, certainly for women a generation ago. I was at an event and I had one woman tell me that her mother had a hot flash in a department store in New York City in the middle of winter, and she marched up to the counter and told the person, "Why did you turn the heat up in here?" Like, it didn't occur to her that because we didn't, again, our vocabulary hadn't caught up to it. That's changed now, right? You can't open your smartphone, and maybe it's just because I'm a woman of a certain age, but I can't open my smartphone without being blasted about menopause. So I think phase one of all of this we've achieved, which is awareness. We're starting to talk about it. I think we have to move into phase two, which is action. What are we going to do about it? Which comes to education. We have to get clinicians that have up-to-date knowledge about these topics. We need public awareness campaigns, which we talked about in the green room. Yes, we need knowledge, and we need better data so that we can translate that into better clinical outcomes.
So related, because where there's a dearth of knowledge, there's room for charlatanism, and we can't go through an aisle at a supermarket without, or watch an ad or something of television without being bombarded with ads for any type of treatment that promises treatment. Trump promises solutions toward any issues that are related to women's health. What do we know works? Or is there anything we know that works?
Yes. If we're talking about menopause, we have options. So, I think, again, for a long time, there's been this idea that stoicism is the answer. Just grin and bear it. You'll get through it. Your mom got through it. Your grandma got through it. You're going to get through it too. Just be stoic. Stoicism is bad medicine and it's bad science. I also want to say that menopause is not a disease. It's not a disorder. You don't treat menopause, but you can treat symptoms if they are debilitating and unwanted and persistent. And so that's where the conversation moves to, if you have severe vasomotor symptoms, if you have intense brain fog, there are options for you. And, we talk a lot in the media, we talk a lot sort of around the table about the Women's Health Initiative study, which maybe we'll get into or maybe we won't, but, sort of older data sets that sort of people are sort of hanging on to and misinterpreting, and certainly physicians that don't have up-to-date knowledge, and I don't want to throw physicians under the bus because they are doing the best that they can with the knowledge that they have. But I think we know that we talk a lot about sort of the risks of taking menopausal hormone therapy, but we don't often talk about the risks of not taking it. And it turns out that for women who initiate menopausal hormone therapy during that perimenopausal transition or before the age of 60 or within 5 years of that, the risks nearly always the benefits nearly always outweigh the risks. And we can talk about sort of patient-specific factors. You should always talk to your doctor about your health history and what makes sense for you. I think that there's ways now that we know how to prescribe it in a way that can alleviate symptoms. And for many women who go on it, the symptom relief is life-changing. I don't want to be a proselytizer necessarily of MHT. Again, you have to do what is right for you when it's right for you in conversation with your doctor. But the point is, don't grin and bear it. There are options, and you should know about them, and you should and we should have, legislatures and, support systems that make these, treatments affordable and backed by insurance.
You may know more than anyone on the planet about hormonal changes in women's brains. What if you had unlimited funds, which you may, but I don't know.
No,
if you had
I wish.
Moonshot, what hypothesis would you test that you haven't yet or that's not in the pipeline?
I love that question. Ooh, so many, and this is where, I think we are as good as the team of scientists that we have to ask this question, which is why I think so much about what the Women's Brain Health Initiative is putting our focus on is training and educating the next generation of scientists, because there's questions we haven't even dreamt of that are, again, lying, this sort of nuggets of gold that are lying just under the surface of our knowledge, and we just have to know where to dig. We're starting. But look what we've done so far. It's kind of creating these brain maps, which sort of feels like this should have been done in the 70s, and it's like, oh my God, we still have to, but there's, I think, a million questions behind each of those. So right now we're laying the foundation of the house, and as we look for the next 10, 20, 30 years, it's really sort of building it all out. So big questions, I'd say right now, that occupy my mind. We do have a partnership, so Welcome Leap, which Pivotal Ventures just partnered with to sort of enhance their support, but Welcome Leap just launched a program called CARE, Cutting Alzheimer's Disease Risk Through Endocrinology. There's 15 groups around the country that came together, so globally, and we were lucky enough to be one of them. So we have a study that's trying to understand how either spontaneous menopause or pharmacologically induced menopause, which we can do by acting on a couple thousand neurons in your hypothalamus, we can target them, we can induce a sort of temporary reversible menopause-like state. So using these two models, and the reason we do the pharmacological menopause is it really takes away chronological aging from the equation. So we can just look at sort of the brain and the body's response to endocrine aging without chronological aging in the works. But comparing these two data sets, what we're doing is really trying to fine-tune the molecular signatures of menopause, like what's going on all around the body that has implications for the brain. I showed a snippet of that data set that we want to take wide, because we know the statistics, and if you were at Robbie Brinton's talk, the first in this series, you know the Stobing statistic, which is that of the 6.7 million Americans with Alzheimer's disease in our country, 2/3 of them are women. Why? We don't have an answer to that very simple question, and I think for a lot of scientists, we think that starting back in the midlife period, in the prodromal period of the disease, because if you start in your 60s and 70s, it's too late. Like, where does that trajectory first diverge? It's probably around midlife, might have something to do with menopause. So I think, that is literally $100 million, if not $1 billion question, because, as we've talked about, having women who, because of poor brain health, exit the workforce early, take on caregiving responsibilities, that is $1 billion, if not $1 trillion hit to our economy. And if we don't solve it, we got major problems coming our way.
My final question before we turn it to the audience. You blew my mind with a fact that there are 4 species on the planet that experience menopause. We are one of them. And I want to know from you, will you explain to the audience what is the hypothesis around that, the grandmother hypothesis, because it's just fascinating.
Yeah, this is a really cool Nature paper from a couple years ago. So, to back up, scientists, humans go through menopause, and we live half of our lives, after the sort of perimenopause, postmenopausal years. That is really strange, because for most species on our planet, they reproduce until they die, right? So insects and birds and other primates, men, this is all true, but it's not true. It's not true for women, and we're not alone. So there's about, 4, maybe 5 other species on the planet that will go through menopause. They're almost all whales. And these fascinating creatures, they tend to live in matriarchal societies. They're highly social. And what we know is that whales who go through menopause live on average 40 years longer than whales who don't, of similar species. So, I think there's this dominant narrative in our culture about, menopause being this disease, or it's the decline, it's a failure of the system, it's the failure of our ovaries. But what if it's not a failure? What if it's actually a feature of the system? And what if something about endocrine aging could teach us something about the biology of longevity? We should look into that. Certainly true of these whale species, and I think there's a lot of science to try to get right to understand what about that is true for humans and how to capitalize on that. Because here's another fun fact: of the 80%, so of all of the octogenarians walking around our planet today, 80% of them are women. We know women, win the longevity race. Now, obviously, lifespan is not the same as health span, so we want to make sure that those are healthy years. But we're doing something right. We've got superpowers within us, and again, let's study women and figure it all out.
Great. There's one right there.
So my question is, as you are mapping a woman's brain during pregnancy and afterwards, have you looked at breastfeeding, and if that has any impact at all on a woman's brain?
Yeah, that's such a great question. We've just started looking at lactation. This is in collaboration with an incredible colleague of ours, Susana Carmona in Spain, who's one of our sister sites in this global. We're looking at the process of lactation, which obviously affects the endocrine system and can kind of prolong that suppression of estrogen, which is why you typically don't get pregnant again while you're breastfeeding. I'm going to sound like a broken record. I don't have data to tell you about sort of the impacts of that on the brain, other than to suggest that I think there's probably some really cool science happening there. I guess stay tuned. I love that question.
Back there's a few.
Maybe as the questions are coming up, I'll just riff on that a little bit, because I think sometimes people ask about why does the brain undergo this change? Is there is this a behavioral adaptation that it's sort of permitting? Which in animal models seems to be the case. I'm happy to go into those details. But in humans, we're way more complicated. And I do just want to clarify that pregnancy is shaping the brain. It may or may not, probably does have adaptive effects on behavior and caregiving, and maternal infant attachment scores seem to be tighter with women who experience more of these gray matter volume changes. But really important caveat: we know that you can be an excellent caregiver without ever experiencing pregnancy. We know this from dads, from adoptive parents, from grandparents. So I don't want to make the case that pregnancy is the end-all be-all. Maybe this is a case of there's many routes to Rome, and pregnancy is one route to get there.
Hi. I am curious. You talk about the brain changing. All women go through menopause, but the brain changing after going through a pregnancy. What happens to the brain when you go through pregnancy, but you've never, when you haven't gone through pregnancy versus going through pregnancy?
Yeah, I think the best way to think about this, so we have a paper in review right now that uses something called a brain age score. So you can use sort of fancy machine learning, and you can basically take of the sort of hundreds of thousands of brain imaging data available through these consortium like UK Biobank and others, and you can look essentially these brain charts across the lifespan. So kind of, imagine when you go to the doctor and you get a height and growth chart. Well, we sort of have these brain charts across the lifespan of the normative bins. And using that data, we can create these brain age calculators. So if you come into the clinic and I give you a quick MRI, and then I feed your brain through the algorithm without ever telling it how old you are, it'll tell me how old it thinks your brain is. And so you can either have sort of a younger looking brain or an older looking brain, or sort of, right on. And so we have this paper using this brain age score, and it suggests that when women go through pregnancy, sort of two things happen. During pregnancy itself, it's like the machine learning algorithm goes berserk. It's like, what the hell is happening? So actually, it's like the brain actually looks like it's getting a little bit older, but then in the postpartum state that lasts probably for decades, the brain actually looks younger than it did before pregnancy. So this probably the story of sort of rejuvenation. We see this in the brain aging clock. We actually see the same thing in these epigenetic clocks, so these kind of cellular markers of aging. So after pregnancy, your epigenetic clocks actually look like they've rewound, which is pretty cool. Should everybody go out and get pregnant? I think that there's a million other considerations that you should have first. And this is what I think comes to your question, like, well, what about women who don't experience pregnancy? I think the analogy I like to give is, I know that running a marathon or becoming a triathlete would be excellent for my body, and yet I am a couch potato. I think I'm healthy. That's not an advantage that I have. Many people have it, but I don't. And I think it's the same with pregnancy. It's like that's one way that, the brain can change and adapt in ways that might be sort of adaptive and great. There's lots of other things that we can focus on. And it's all the stuff your mama told you about: eating well, exercise, getting good sleep. I think sleep hygiene is really important. So.
But hold on one second. If it were to be shown to be optimally beneficial for a woman's brain to experience pregnancy, like HRT, couldn't we find a way to mimic that?
Okay, excellent question. So this is where I get really excited, because I was listening to a radio lab on Gould Dolan, who's this fabulous neuroscientist at Berkeley, in my home department is where I got my PhD, and she studies psilocybin and neuroplasticity that happens with psychedelics. And she does mainly animal models, but showing, and this is sort of now, I guess, common knowledge, but like these, psilocybin can create this extraordinary windows of neuroplasticity. And I remember looking at those data and being like, we possess, like, the biggest trip of a lifetime is pregnancy. Like, we get those hormones that rush, they open the brain up. So yeah, I mean, the question is, can we basically like boil that down into druggable targets or sort of ways in which, if we can like really understand the biological basis of that, how do we then apply that knowledge for everyone to promote brain health, whether that's, a veteran who's coming back with a traumatic brain injury, or, a 60-year-old male who just experienced a stroke. Is there basic biology in really paying careful attention to this wonder of the neurobiology of matrescence that could benefit everyone? And I think the answer is yes. Again, inch one of the marathon, but let's keep going.
Mm-hmm. Yeah.
Given that there's so much to learn and ask, if you were to ask a question on post-menopause, what would you be curious about? You touched upon it with women living longer, but along with that is, have you thought about DHEA, the youth hormone, and exosomes, the precursor of stem cells, as providing more brain neuroplasticity?
Yeah.
And because brain fog and more energy can come.
Yeah, I think the science of longevity science, the biology of longevity is a fascinating area. I think it's definitely where we need to go. To be honest, me personally, and there's brilliant people working in that space of sort of aging science, I'm kind of more interested in dialing back the clock of saying, like, what's happening earlier in life that can set the stage for healthy brain aging trajectories. Because I think that's where we get to deal in the realm of kind of modifiable health factors, whether it's, really modifiable diet and sleep and exercise and all that, or even sort of thinking about these endocrine transitions, and or thinking about menopause and the fact that, like, we can already from this sort of prelim data start to see these risk proteins that are notching up in women. Well, many of those are inflammatory pathways. These are druggable targets. If we could intervene, can we change that statistic of women representing 2/3 of the 80 Alzheimer's disease cases by the time they're 70 or 80? So I'd say my bias is really rewinding the clock and looking earlier.
How about way back there?
What are you hearing about studies of the effect of alcohol on women's brains?
I've got bad news for us, friends. I don't think it's good. I think the latest is that, it's not good. But, I'm also of the persuasion that I think everything in moderation. But yeah, I'd say the science is that it's not great for the brain. But I think if you take little bits, living near a freeway and particulate matter is not good for the brain, and yet billions of people around the world experience it. So you have to choose your vices to the extent that they're choosable. But
right here on the aisle, making you run.
Hi, I have a question when you're talking about dialing it back. And I think I saw on one of the slides that during birth control, there was a correlation between depression. And what do you know, or have you done research on birth control with brain health?
Yeah. Oh, the $1 million question. I could give a long-winded answer. I'm conscious of the time. So actually, it was that very question that launched the entire brain bank. Would you believe? Because I had a brilliant postdoc, Caitlin Taylor, who now is director of operations for the brain bank, who came to me and said, you are a neuroendocrinologist, you study hormones in the brain. I want to understand how birth control influences the brain. And if I'm being totally honest, my response was, I think that's a fascinating question, and I'm not sure I want anything to do with it. And that was obviously a dumb response, and it lasted all of 20 minutes, and then I sort of woke up and I said, okay, but if we do it, we have to do it right. And we published a paper in Nature Neuroscience documenting the neuroscience of hormonal contraceptives, and at that time, which was a year ago, there was 30 papers ever published. Of the 50,000 articles, this is something that most women experience in their lifetime, and we know basically nothing. And most of those studies are underpowered. There's confounds, and yet, we have women around the world who are, this is maybe one of the largest uncontrolled medical experiments happening because women are taking it, and obviously it's having an effect on our endocrine system. And I'm of two minds. I think on the one hand, we need access to essential medication that is used for a whole bunch of reasons, whether it's contraception, endometriosis, PCOS, et cetera. And especially for women who are taking it for contraceptive purposes, we can ask, I think, fairly the question, if you're taking a medication for a targeted effect, like controlling, controlling pregnancy, hormones don't have targeted effects. That's actually just not how they work. The endocrine system is like the big integrator. So if you think about why we have an endocrine system, it's because these organ systems have to talk to one another. So as a result, any form of medication like an OC, if you want it to have a targeted effect, it's going to have all these off-target effects. It's the same thing I say for, people who take anabolic androgenic steroids, which is a controlled substance. Interesting. That you might take it for muscle mass, but you're going to have a whole bunch of other effects from, enlarged heart and cystic acne to, everything. So I think we have to ask I think public media, the sort of public discourse doesn't handle nuance well, and I think we have to ask really nuanced questions, which is not, is birth control good or bad, but who is it good for, and when, and under what considerations, and for how long? So thinking about age of initiation, duration of use, we need to know the brand name so we can kind of reverse engineer the formulation and ask how, sort of questions about brain health. So I think, and there's a wonderful op doc by an LA filmmaker named Cinda Aga, and it's called Birth Control, My Own Adventure. And she talks about her personal experience of, on the one hand, I want to defend my right to access this essential medication. And on the other hand, I want to know more. And both of those things can be true, and I think are true for me. So that's truly why I was like, okay, if we do this, we can't have an underpowered kind of BS study. We need to ask and answer the question completely because the consequences are profound. And I think that Wouldn't it be lovely to say, for 80% of women, it's fine, actually. It's fine. The benefits far outweigh the risk. And we've, taken this since the 60s. We're not growing a third arm. But maybe we can talk about, the risk profile for the 10 or 20% of women for whom there's actually like a real mental health risk. That's where I want to get, sort of precision medicine, so we can ask better questions and give women better answers.
And that's all the time we have. Thank you, Dr. Jacobs. Thank you, everybody, for being here.
Thank you.